Okay, so far we have been working with standard controller, right? So which means we are not writing the logic, we are just calling the controller, right? The existing ones. Okay, now the good thing about using a standard controller is that you don't have to do anything, you just have to call the controller, right? But there is a challenge. The challenge is that you are restricted to the default logics of the Salesforce pages, right? So you're not able to create your own actions, you're not able to create the pages with the logics that you want. All right, so for that reason what we need a custom controller. In case you want to create a page or as per your own requirement, you want to define logics as per your requirement, then you'll have to go with a custom controller. Okay, so now we are gonna start talking about custom controller. How do we create a custom controller? Now when I say custom controller is where I'm gonna write the logics, I need a language to write the logics, right? Visual Force, obviously by now we have understood that Visual Force cannot be used for writing logic. It's just a markup language. It can just be used for designing the front end, right? So for writing logics, we need another programming language. Which language we are going to use for writing logics? Which language are we going to use for writing the logics? Anyone? Apex, yes. Apex is what we are going to use for writing the logic. So before I get into the custom controller part, we are going to understand a few basics about Apex. So I'm going to talk about basics of Apex today, and we'll understand what are the different data types and all in Apex which can be used, and then we will get into creating a custom controller in tomorrow's session. All right. Okay. Now give me one quick moment. Yep, here we are. Yes. Okay. So Apex is a proper programming language, right? Proper programming language means you will have the option of defining variables, you can write conditions, you can write loops. Okay. So all these things can be done in Apex. Now, and Apex is a strongly typed programming language. Okay. What does that mean? Strongly typed programming language means a programming language in which uh, every time you define a variable, you have to define the type, the data type for the variable. Okay, so if you're defining a variable x, you have to define what data type you want to store in this variable, like say string x. Now this is how I have to define it. I cannot just define variable x, I have to define the data type for the variable as well, and that variable can be used for storing that data type only. Now x can only be used for storing string. Okay. Similarly, if I have to define a variable for integer, I have to specify that this is for integer, and this I can now be used only for storing integer values. Got it? So that's how it works. Uh, so first thing that we're going to do, we are going to understand what are the different data types that can be defined in Apex. Now, since we understand that we always have to define a variable and we always have to specify the data type for the variable, let's understand what are the different data types which are allowed. So in Apex, we can define primitives. The data types which are allowed are primitives. Primitives are the normal data types which are used in other programming languages as well, like string, integer, boolean. So these are the primitives. Boolean is basically a data type which can only hold a true or false. Okay. Decimal, a number that includes a decimal point. Double, a 64-bit number that includes decimal point. ID is the data type which can hold any Salesforce.com ID. Integer, 32-bit number uh, that does not include decimal point. Without decimal, a whole number. Long, 64-bit whole number without decimal point. String, set of characters. Date, you all understand, date, time. So these are the primitive data types. So we can use these data types in the while we are defining the program. Okay, and defining a variable with these data types is pretty simple. Like if you have to define a string, it's pretty simple. String s equals something. Integer I equals 20. Stuff like this. All right. So these are the primitive data types. Apart from primitive data types are the ones which are used in other programming languages and are very generic. Apart from this, there's another data type which we use in Apex, which is S-object. S-object stands for Salesforce object. Okay. Now, see, if I have to define a variable which can hold a string, then I can easily go ahead and define it this way, right? Simple. If I have to define a variable which needs to hold an integer, I can use this integer data type. What if I have to define a variable that can hold a complete record? Think about this. If you have to define a variable that can hold a complete record, then which data type you are going to use? Let's say I have to define a variable which can hold a complete account record. Then which data type we are going to use? Then we are going to use S-object. Okay. Like if I have to define a variable which can hold a complete account record, I am going to define it like this. Account A. Okay, so this is the variable name and this is the variable type. So all your Salesforce objects can be used as data types for Apex programming, and these data types are called S objects. All right. Okay. Now account A is a variable which can hold a complete account record. We can write here equals new account name equals okay, whatever. So you see this. Now this A is a variable which can hold a complete account record, and this is how you can define the value into this. All right. If you want to fetch individual values like industry from this A, you can also do it this way. Industry equals A dot industry. Okay. So A is a complete record. You can say A dot industry to fetch a particular value from a field from this account record. All right. So this is how simple it is. Same way, if I have to define a variable for storing opportunity, I should define it like this: opportunity O equals opportunity and give it a name, something like this, and all the details. Got it? So that's how it is. So this is the other type of data type, which is S objects. Okay, for any object we can define variables, and that's called S object. So there are two data types which we have seen: primitives, the generic ones, and the S objects. S objects are very specific to Salesforce or Apex programming only. You won't find S object data type in any other programming language. Okay. Apart from primitives and S objects, we have got a few other data types. The third one is a list. Okay. Now, what is a list? List is basically collection of primitives or S objects. Okay, a list is an ordered collection of primitives or S objects. So sometimes you will require data types which can hold multiple values, right? We'll need that, like one variable that can hold multiple string values, or one variable that can hold multiple account records. That's done using that's defined using list. All right. So list is basically an ordered collection of primitives or S objects. Now, what does a list do? List allows you to define variables which can hold multiple values, like uh, list of string. So this is how it is defined. List of string colors equals new list of. Okay. Now this list basically includes multiple string values. Got it? So this is how list of string is defined. Same way we can have list defined for S objects as well. Okay, I'll talk about that, but before that, a small concept here. The list is an ordered collection. Now, what does that? What does this ordered collection mean? Ordered collection means every value in the list has got an index number. Just give me one quick moment. One moment, please. Hello. Yep, I'm back. All right. Yeah. So we were talking about this list, right? So list is ordered collection. Ordered collection means the values which get into this list are in a certain order. Okay. which means that every value in the list is in a certain order, and that's the order which it follows. I'll show you an example. Okay, let's look into this. This is a list, okay, and there are multiple values here. You see every value has got an index number. This is the first value in the list. Let's say this is a list of strings. Now the first value has got an index number 0, second one has got index 1, third one has got index 2, index 3, and so on. Alright, which means every value has got an index number, and that is the order in which they basically have got into the list. Okay, now what happens in this case? Every value, because it has got an index number, the values are identified by the index number and not by the actual values, which means which would mean okay, now what is the index number of red here? Let's say this list, what is the index number of red? Can anyone tell me? 0. What is the index for green? 1. Index of blue is 2. Now good thing here is, if I add one more red, okay, what will be the index number of this red? The one that I just added. What's going to be the index number of this? It's going to be 3. Okay, okay, now this red and this red are going to be considered as two different values. Why? Because the index numbers are different. Okay, so both these values will get stored in the list, and they are going to be considered as two different values because index number is the identifier, and they both have got two different index numbers. Okay, so there is a different index number for this red, and there is a different index number for this red. So for that reason, these two reds are basically going to be considered as two different values. Correct? So in a list, duplicate values will be allowed because the values are identified by the index numbers. Alright, and every value will obviously have a different index number. Correct? So that's what a list is. Now the good thing about list is that you are able to fetch the values based by index number. Like if you want, if you say colors dot get 2. Okay, if I say this, what value do you think it's gonna return? Colors dot get 2. Which value you think it's gonna return? It's gonna return blue, right? So that is the thing. So this is how we can basically go and work with a list. Anytime you have a requirement where you want the duplicate values to be allowed in the list, we work with a list. Okay, now there is one more similar data type which is called a set. Okay, set is an unordered collection. Set is unordered collection of primitives or S object. Okay, set is basically an unordered collection. What is this unordered collection? Unordered collection means there is no concept of the index number. There is value, and value itself is the identifier. So let me show you another example here. Look into this. Now if this is a list of values, now this is basically set. All right, here every value itself is the unique identifier. There is no index number concept. All right, so we have got San Francisco, New York, Paris, Tokyo. Okay, so let's say this is what I have here. So if I define a set, the values set is going to be defined in the same way, the way we define a list. We can define set of string cities, let's say, equals new set of string we define SF and then we define and then I say Paris. Okay, now in this set there is no index number concept, which means the value themselves are the identifiers, unique identifiers. Okay, there is no index number. Now what will happen if I try to enter one more Paris here? What do you think is going to happen if you try to add one more Paris here? Do you think it will get added? It won't get added. It won't throw error basically, but it won't get added. It is just gonna have one Paris value added. Okay, it finds that okay, when you try to add one more Paris, it will see that okay, it already exists and it's not gonna add that. Got it? So the value is already there. It won't add it. So ultimately, this collection is only gonna have 1, 2, 3 values. Now I'm trying to add 4. Okay, because Paris is a repeat and set does not save repeat values, so it's just gonna save one value. In this case, red is a repeat, list can store duplicate values, so it's gonna store that. Okay, so that's the concept. That's a slightly different concept with list and set. All right, okay, so that's how it works. So that's basically about set. Now there is another concept which we are going to discuss, that's about a map. All right, so we have talked about list and set. Now we are going to talk about map. What is a map? Map is basically collection of key value pairs. Okay, what is a key value pair? Key value pair is key value pair is, let's say I have got countries and currencies. Okay, let's say I've got countries and currencies. India, INR, US, USD, Australia, AUD, Canada, okay. Now here we are talking about key value pair. Okay, so this is a collection, but it's not collection of just one set of values, it's a key value pair, collection of key value pair. In key value pair, left side is the key and right side is the value. Okay, and key has to be unique. In this collection, key has to be unique, value can be duplicate as well. Okay, so how do we define a map? To define a map, you define it like this. My key is gonna be in string format, value is also in string format. I can define it like this: currencies equals you see this? So this is how it is defined. More. So left side is key and right side is value. Key has to be unique. Okay. Now if you try and understand it properly, you will find it very similar to list. List was also similar kind of thing. Their index number was by default playing the role of the key, right? Index 0 value was red, index 1 value was green, index 2 value was blue. Here instead of index number we have actually defined we've given specific values to the keys also. India value is INR, US value is USD. Now you want to fetch the value from this map. You want to get the currency of Australia. You can get it this way: string Australia currency equals currencies dot get see this, it's gonna return this value. Got it? So that is the thing. So if you look into this, I mean, if you don't understand that aspect, you can skip it right now. But if you compare it, it's pretty much similar to the list. In list, by default, the index number was acting as the key. There also it was kind of a key value pair. Okay, so we did not talk about that, but it was kind of a key value pair only, right? Against every index number there is a value there, right? Same thing is happening here. Here the only difference is that because this is a map, we are able to define, we are not using the index number, we are using specific values, right? So that is, key always has to be unique. You cannot have two repeat of the key. Value can repeat, like for Canada also you can have USD, values can repeat. Okay, so there is no problem with repeating the values here. All right, so these are the different data types which we are basically gonna use. We're gonna use the primitives, which are the simple ones, S objects, which are like the Salesforce object data types, which we use in Salesforce. Then we are gonna use the list, which is basically ordered collection of primitives or S objects, set, which are unordered collection of primitives or S objects, and maps. Alright, so these are the different data types which we are going to use in the Apex programming overall, not just for the controllers. Now using these data types, which we are going to create our custom controllers. Alright, using these data types, we will start working with our custom controllers. Now before we can get into the custom controller part, before we start writing controllers, there are a few other concepts which we need to understand, which we're gonna discuss now. Data types we have understood, right? Now we will need to understand methods and classes. Okay, a data type, as we can say, data type and a variable. Variable is what? It can only hold a value, right? What's a variable? Variable is a container which holds a value. That's it, right? Can it do anything else? No, it cannot. If I say string s, what can this variable do? It can only hold a value, right? It's just a container which can contain a certain value. It is not capable of doing anything. It does not have any instructions. It cannot hold instructions to perform any action. Right? So variables, only defining variable is actually not going to help me. I also need to define methods. Methods are basically the set of instructions which have the information of what needs to be done and not. Alright, like let's say I have got two variables, integer x equals 10, integer y equals 20, and then these are just two different variables. Now I can define a method called add, and this method will add these two values. Result equals x plus y. Got it? So I have got two variables and a method. Method add is basically going to add these two values. Same way I can have another method. Okay. See this? So now the actual action is defined inside the methods. Alright. If you call the add method, then the result is going to be 30. If you call the multiply method, then the result is going to be 200, right? So what needs to be done with these variables, that's defined inside the methods. All right, so method basically holds the instructions of what needs to be done. All right, now that's the simple understanding about method. Now, apart from method, what else do we need? We need to define these methods inside. So let's say variables are there, then methods are there. Now you have to define all these things inside some boundary. Okay, like these variables are there and then these two methods are there. I have to put all these code together as one single piece. Okay, this entire code can be put together in a class. This entire thing can be defined as a class. This complete thing can be defined as a class. Got it? So a class will basically have the variables and methods defined inside it. Okay, there are a few more, very technical descriptions about class, but don't get confused with that. People who are already, who have already worked with a class and all, they would know. People who do not understand, just keep it very very simple. So a class is something which is going to hold your variables and methods, because variables and methods I have to put together in one place, right? Like when you are creating a document, a Word document, all the important pieces of that you need to store that as one single file, right? You cannot save half of it in one file and another half of it in another file. Same way, if I'm actually calling a variable in a method, so these variables methods all need to be put inside one particular boundary. That's the class. Okay, that's the basic understanding of the class. So a class will basically have the variables defined, it will have the methods defined. Alright, so what I can do here is, let's okay, let's define this class, and I'll call this class as mathematics class. Okay, yeah, okay, so I have, so I've defined a class called mathematics. Inside that class I've got two methods, add and multiply. Got it? Now whenever you need to call this, you can call it like this, mathematics dot add, means class dot method name. This is how we can actually call this method. Alright, so this is how your code is written. So all the variables which are specific, or all the methods which are going to use the same set of variables and or all the methods being defined for the same sort of functionality, they are usually written inside one single class, right? So that's how it is. So my class will have a name. Now this is the name of the class. Mathematics is the name of the class. It will have the variables which are to be used. It will have the methods. Fine. So that is the thing. Now this is the logic which we are going to use for our custom controller as well. This is exactly the same logic which we are going to use for our custom controller. We'll create a class. Okay, and we talked about this. We are gonna, for custom controller, we are gonna define a class, and we are gonna call the class as a custom controller on the Visual Force page. Okay. Now, as I said, we are gonna write our own logic. Let's say this is our Visual Force page. This is the Visual Force page. We want to use our own logic here. So what we will do, we'll create a class. We'll define a class using Apex. Okay, and we are going to call the class as a controller on the Visual Force page. Now the next thing is that if there is any functionality that I want on the page, that will be defined as a method here. Once I call this class as a controller on the Visual Force page, I should be able to call those functionalities on the visual force page. So whatever you want to do, you define any particular method or any actions, those need to be defined as methods here in the controller. Fine, simple. So this is what we are going to do. So we'll talk more about this in tomorrow's session. We'll continue to discuss on this, and we will see how we can actually define a class and what sort of methods can be defined for visual force pages. Now you guys can let me know if anyone has got any question for today. Okay.